This conference will now be recorded.
Okay, so this is where we are, and in yesterday's session, we were discussing the primary difference between a .NET full framework application and a .NET Core application, from how it gets built and how it gets restored from a perspective of restore and build. And we said that the biggest difference, or we kind of concluded that the biggest difference between a .NET framework and a .NET Core application is primarily in something known as a restoration procedure, wherein a full framework uses something known as a service called NuGet to go ahead and restore its dependencies. A .NET Core doesn't have to go ahead and explicitly download a tool called NuGet. NuGet now is an internal part or an intrinsic part of the .NET Core, the .NET Core application itself. So it doesn't have to go anywhere to go ahead and download the tool and then restore the dependencies. It is a little faster. And also .NET Full Framework uh, is platform dependent, meaning you can only run this application on virtual machines or web applications or any type of servers that are built on a Windows operating system, while .NET Core is platform independent, meaning you do not, I mean, it doesn't really concern, or it's not really concerned about what is the underlying operating system of the virtual machine or the web application on which it is running. You can have a Mac OS, you can have a Linux, you can have Send, Debian, Windows, whatever it is, it can go ahead and run on top of it. So this is what we are discussing. Just I'm just doing a quick recap on what we are discussing yesterday. And now let's go into our Azure DevOps and let's see how can we use the knowledge that we acquired yesterday and implement it today out here. So I am inside this project right now, which is called 7am class project. And until a couple of days, what we were doing, or what I was doing rather, is that we went ahead, we established, we basically got an understanding of what are repositories, and then we said what is or what are branches inside the repository. So A, we know what is a repository right now. B, there are branches inside the repository like develop, like main, and etc. And finally, we went ahead and said there are something called as branching policies. So we also went ahead and established something called branching policies out here. So that this, we established that this was going to go ahead and protect our branches from, let's say, from default, I mean, from a faulty code quality. It's going to go ahead and protect our branches. So this is what we really said, or this is what we really spoke about until now. And as of now, I have a .NET Core application, the code that belongs to a .NET Core application, and the code that belongs to a .NET Full Framework. I have both of them in my repository right now, and I will now have to go ahead and convert this code and start converting this code into a binary language. And this process, as I said, we call this process as a build process, and we use a service called as pipelines in Azure DevOps in order to help us build this code, in order to help us convert this code from a very high level language to a low level language which the server can really understand. So what I'll do here is I'll go here into the pipelines, and it has multiple services like pipelines, environment releases, and etc. I'm interested in one particular service called pipelines here. So I just click on this, and it now says, hey, you know what, create your first pipeline, etc. So I'll say create the pipeline. And now it's asking me, I understand that you want to convert a code from a high level language to a low level language, or binaries or DLLs, or in Azure DevOps terminology called artifacts. So it's now firstly asking me, where exactly is your code? Like, how do you want to build your code? Where did you store your code? Now I know my code is in something called as Azure Repos Git, and it's telling me that okay, fine. Do you want to write a pipeline or do you want to design a pipeline? Now, writing a pipeline is the modern way to do it. But firstly, let's understand how do you design a pipeline to get a better understanding of it. And once we get that, we'll go ahead and also write our pipeline. We'll also basically write our pipelines also. So what I'm going to do is I'm going to use this button called use classic editor in the bottom. I'm going to click this, and this is going to take me to the next screen, which will again ask me the same question, telling me that can you select the source control, meaning where exactly is your code? Is your code somewhere in Azure Repos Git? Like, is it something like in the Azure repository, or is it something in a GitHub repository? Or is it something in a GitHub repository? Do you have something called GitHub Enterprise Server, or do you have a subversion? All these that you see on my screen are examples of source control or examples of version controls that are available out there in the market. So I say that okay, fine, my code is not in GitHub or in the GitHub Enterprise and etc. My code is in something called Azure Repos Git. This is the source control that I use because this is the service called Azure Repos, which I use to go ahead and store all my code in there. So I'm now saying, okay, fine, the code is here, which is called Azure Repos Git, and please look into a project because I have multiple projects out here. So please look into a project called 7am class project. This is the one that I'm actually looking into. Please look into a repository called first repository. This is the one that I created. And please look into a branch called develop branch because I am not working on a main branch. In here, it's by default taking something called as a main branch. But I know that I stored all my code in the develop branch. And based upon the project and based upon the branching and merging strategies that I have, it is telling me that okay, fine. It is telling me that okay, fine. This is the develop branch, and you have all your code inside this. So I'll change my branch. How do I do that? I'll just click here, and there are a couple of branches out here that's getting displayed. So I'll now select the develop branch from this particular drop down, and I'll say continue. And as and when I do that, it's now telling me that okay, fine, I understand your code is in develop branch, but can you tell me what kind of code you want to build? Like, what is the language in which you're building the code in? What is the language in which you're building the code in? Meaning, did you write the code in .NET, or did you write the code in, let's say, Java or Python or Golang or whatever it is? Which language did you kind of build your code in, or which language did you write your code in? That's what it's asking me right now. So in here, you have a lot of things. For example, if I click on Java, you have a couple of things like Gradle and all that stuff. And if I say .NET, you have multiple things again like .NET Desktop, ASP.NET, and if I go down, you have ASP.NET Core, you have ASP.NET Full Framework, and etc. So I know that I have a code that is built, or I have a code that is written in .NET Full Framework, and I have a code that is written in .NET Core. I have two things out there in the same repository out here right now. So what I'm going to do is that I'm firstly going to create a build pipeline for a .NET Full Framework application. And then I'll go ahead and create a build pipeline for .NET Core application because I have two different ways in which I have written the code, and these two different codes needs different way to build it out because that's how they are kind of configured, and that's how they are written out here. And there is a strategy that I need to follow to build each and every kind of a code out here. So what I'm going to do now is that I am firstly going to look at this code only, which is .NET Framework, and I'll say it is ASP.NET application because it's an ASP.NET Full Framework application. I know that it's a full framework application, so I'll say apply. And as and when I do an application, it went ahead and it created a pipeline for me. All this that you see is the pipeline. So let's go ahead and get a little bit of understanding on what this is trying to do. So let's do this. The first and foremost, this is called a stage in the pipeline. This is called as a job, and all these are called the tasks. Three things basically that construct a pipeline. So first thing is called a stage, the second is known as a job, the third thing is called as a task. So stage plus job plus task is going to basically give you this entire pipeline out here. So this is the constitution of a pipeline. Now then, what exactly stage? Let's understand this in a bit detail. So if I click on the stage, I have some options in the right hand side, wherein the first thing it's telling me what is the name of the pipeline, and now it just took a random name called 7am esp.net ci. So what I'll say is that I'll say this is a .NET full framework pipeline. So I'm just writing something called .NET full framework pipeline. I'll say hyphen build because it's a build pipeline that I'm kind of creating out here. And the very next thing it's asking me out here is what is the agent pool and what is the agent specification that you want to choose out here. What exactly is this? Like, let's understand this a bit further because this is a very, very, very important concept. So let's understand this a little bit further, and I need some inputs from you all guys to explain this out. So I have created this particular application on my local machine, right, using Visual Studio. So I had this code in Visual Studio. This is the code basically that I have created in my Visual Studio. And once I created this, I went ahead and I clicked on build my application. And the process of build here is nothing but conversion of a code from again a high level language, which is human readable in nature, to a machine language, which is called DLL or artifact. Now, in our case, we are using a DevOps practice in order to convert it out, meaning we are not using our local machine. We are not using the local machine to go ahead and do the build process. I am just using my local machine in order to go ahead and write my code. I'm not building my code. There is a difference between writing and building the code. I'm using the local machine to write my code, but in order to build it, I'm now saying that I will go ahead and use Azure DevOps. But the question, sorry, the question now for you all is that if I want to now build my code using my local machine, what all do I need and what should I do now? So I'm expecting some inputs from your end, guys. So please go ahead and mute yourselves and tell me what you understand by this. Guys, I need inputs. Without that, I cannot move forward. So once I get the inputs, I'll then start telling you what it is.
Local, if you click on project, we can build
Mhm.
the code in local, like by right
In
clicking.
mhm. So if I click here, then I can go ahead and build the application.
Yes,
So let's say if I don't have an application installed, or let's say I don't have a software called Visual Studio installed on my local machine. I don't have this. Then how do I build it out? I mean, just a situation out here. So I'm able to build it because I have this software called Visual Studio. But what if I don't have this? Yes, go ahead, guys. Any inputs here?
Compiler.
Compiler. So correct, compiler. But Visual Studio now is acting as my compiler. Visual Studio out here is acting as a compiler. So you will need this software, right? I mean, you cannot remove the software out of your local machine. So you will need the software. And this software to be installed on your local machine. Now I'll give you a situation out here is that your local machine has about 256 MB of RAM, okay, which is like very, very, very little. Can you go ahead and install the software? Yes, no, maybe.
No.
No, right? Because this software needs some amount of hardware, meaning I'm talking about a hardware. In my case, I have, let's say, somewhere around 8 GB of RAM and I have 1 TB of hard drive and all that stuff. So I need some physical attributes out here. It's nothing but in the form of RAM, in the form of hard drive, or hard drive, in the form of memory and all that stuff. So I am only able to build the software. I'm only able to build it because I have Visual Studio installed. I have a hardware, I have a hard drive hardware and etc. And I also have, very importantly, in order to understand all my commands, I have an operating system, and I have a Windows operating system which is capable of building this code. Because it's a .NET full framework, of course. So I have a Windows operating system which is capable of building this code. So all these things is acting like a compiler for me, which is going ahead and converting, which is going ahead and converting this code from, let's say, a high level language to a low level language out here. But I am now telling that I'm now establishing a norm that developers are not allowed to build the code on local. This is strictly not allowed. Reason being, again, you will have configuration issues and a lot of issues basically actually come in. So that's the reason I'm using Azure DevOps right now. So I want to go ahead and build my code on the cloud. So I want to do the entire build process using a cloud tool called Azure DevOps. This is also called ADO for your information. We call it as ADO, ADO in short. So ADO, Azure DevOps, is the same thing out here. And I want to do the entire build process using Azure DevOps right now. So if I want to use the cloud, then who is going to provide me this Visual Studio? How am I going to get the hardware? And how am I going to get the operating system out here? Because these three things are essential for me, right? These three things are essential for me to build my code. But if I go to the cloud, then how am I going to get all these three things? So any thoughts on this one? Anyone, any thoughts on this one? So if I'm moving to the cloud right now, then sorry, who is going to provide me all these things out?
Azure
Network.
DevOps.
I'm sorry.
That's with the net connection, sir.
I'm sorry. Can you please go ahead? I'm sorry, I didn't get your inputs. Can you please go ahead, Nagesh?
We use tools in Azure DevOps.
Tools in Azure DevOps. Okay, tools in Azure DevOps.
The agent
Meaning
hosting.
agent hosting. Okay, agent hosting. Let's see, agent hosting also. So tools in Azure DevOps, agent hosting, fine. Meaning, in order to put it in a very simpler term, I need someone or somehow to provide me something like a hardware. I need
Hmm.
someone to go ahead and provide me the OS, and on top of the OS, I need someone to install the Visual Studio software and give it to me right away. I need all these three things, even if I move to the cloud. So, what I can do is that I don't have a physical machine on the cloud right now. Rather, I have a virtual machine. We read about this concept, and we did a lot about this concept called virtual machine, on which I can install Visual Studio, on which gives me something like a hardware, which also has an operating system. Meaning, I can leverage this concept of virtual machines, which is on the cloud, like a cloud like let's say Azure, install all these things and help me build this code. Now, if I do this, this virtual machine is called a build agent, or just agent in simple words. It's called an agent machine right now. And this type of an agent is called self-hosted agent. Why am I calling it a self-hosted agent? Because I am going ahead creating this virtual machine, installing the softwares that I need, and then converting this machine into a build server. This is called a self-hosted agent. But what if I don't want to go ahead and create this machine? Because again, there's a cost associated with it, there's some management associated with it, etc. And I request Microsoft to do this for me. If I'm requesting Microsoft to do this for me at, let's say, a very minimal cost, that kind of an approach is called a hosted agent. There are two types of things out here. One is called a self-hosted, wherein I go ahead, go to my Azure portal, create a virtual machine, convert it into a build machine or a build agent, or I get a machine that is ready made for me, and this machines or the service is called a software as a service. So it's readily available, I need to consume it. This type of a service is called as a hosted agent out here. So where do I get it? How do I select it then? Is in here. If you look at this, if you look at my stage, it just asks me for what is the name. Secondly, it's asking you what is the agent pool. Meaning, do you want to go for a self-hosted machine, or do you want to go for a Azure hosted machine, or let's say a Microsoft hosted machine? And if I look into this, and if I just click on this drop down, I have something called a hosted pool, which Azure is offering me. It's called Azure Pipeline Agents. And I have something called as a private agent. Private agents are a different name for self-hosted agents out here. So to begin with, I will just tell that, you know what, I just need a Azure Pipeline hosted agent. This is the machine that or this is the service that I'm going for. And then it's asking me what is the agent specification. And if I just click on this, it's just giving me tons and tons of flavors out here. But since this is a .NET Full Framework application, I'm only interested in something like Windows out here. So here it is telling me VS 2017 hyphen VS 2016. What does this mean? Is that it will give me, or this service is going to give me, a Visual Studio 2017 version installed on top of a Windows Server 2016. Or if you want to go for something latest, you're going to get something called Windows 2019, meaning a Windows 2019 server with the latest version of Visual Studio, or a Windows 2022 server with the latest version of Visual Studio, or whichever is the latest that is available with Microsoft. Like at this point, let's say there's only there's only 19 with them. They are going to provide you the 19 version of it. So what I'll do here, in order to be on a safer side, I'll just go ahead and select the Windows latest. So I am saying that whatever agent that you are provisioning me, meaning Microsoft is provisioning me right now, I'm saying I need it with the latest configuration. So please go ahead and give me or please go ahead and provision an agent with the latest configuration out here. This is what I'm just telling Microsoft out here. So this is what the agent phase really means. So any questions till here, guys? Anyone, anything till here? Anyone, any questions before we move forward? Okay, so finally, it's now also asking me one more thing, is that what do you want me to exactly build? And it's telling me it is dot something something SLN, meaning it's doing a star here, which is called a wildcard. So it is telling whatever is before a slash and whatever is after a slash with a dot SLN. This is the pattern that I'm looking for. It will try to see whether the extension is a dot .sln, and it will try to target that file. Meaning, in my case, if I go into my repository, I have a .NET Core application also, and this .NET Core application also has a .sln file, and the .NET Full Framework also has a .sln file. So what I'm going to do out here is I'll just select the path of my .NET Full Framework, which is .NET Full Framework application / something like this. I'll just copy this out and I'll specify this as the path. So I'm just saying this is the path. I don't want you to target something random, but I want you to target one specific solution file which is matching this particular path. So I am now targeting only my .NET Full Framework application out here, and this is the main file of the application. This is called as a solution file. Even when you build it in the local, I mean, even in, let's say, when you create it in the local machine, you have the solution file out here. So you click on the solution file and you basically build it out. So I am basically only looking at the solution file out right now, and I am saying please go ahead and target the solution file out here. And finally, it is now telling me that okay, great, I know that you want me to convert all this code into something called as an artifact. Then how do you want to store, or what do you want to do to store this artifact? I will say create a folder called drop. This can be anything, it can be ABC, ABCD, something like that, but drop is the standard convention what we follow out here. So I'm saying create a folder called drop, and whatever the code you compile, meaning whatever the code you have converted, store it in this particular folder called drop on the cloud. This is what I'm telling, and this is called artifacts staging directory. You can either call it as drop, or in a technical terminology, we call this as the artifact staging directory. meaning this is the folder inside the VM. Which VM? Again, it's the agent machine that I'm talking about, in which your compiled code is stored. So this now is called as artifact staging directory out here. So please remember this terminologies, guys, because Azure DevOps, you in Azure DevOps, you will start using all this technical jargon out here. That's the reason I'm trying to make this introduce to yourself. I mean, introduce to y'all. So artifact staging directory is nothing but a folder inside the agent machine, and not any folder, but one specific folder called as an A folder. So I'll explain about what A folders, what folders and etc. are inside the machine. But I'm just giving you an idea about what happens out there. So I'm just calling this as a drop folder, and this is all the settings that I'm mentioning at the stage level. And once this is done, there is something called get sources, wherein this is the first page that you selected. You started here, you selected that that's Azure repos and etc. You can also change it here, but I do not want to change it at this point. And it looks something like this, and I'll talk about all these options out here. But for now, you can go ahead and let's say change your project, change your repository, and do all of those things out here also. You can change the repository, you can change the branch and etc. But I don't want to do that at this point. I'm good with my source. My source is Azure repos, my project is 7am class project, my repository is this one, and the branch is developed. I'm good with this. Finally, there is something called as an agent job. What do I mean by an agent job out here is that now you are using a self-hosted machine, and this self-hosted machine needs to perform a series of tasks, or let's say a series of work, which will help you convert the code into binaries. This is what this is what the machine has to do, and all these tasks which the machine performs are together called as jobs, or are together called as a job. So this is now telling that okay, fine, I have something called as an agent job, and under the job, all these are the tasks that I need to perform to go ahead and convert the code to go ahead and convert the code into something known as a DLL or the artifact. This is what I need to do. So I am just mentioning what is the job of the agent, and under the job I am going ahead and mentioning what should the agent actually do. And if you look at the job out here, it has a couple of options called demands, execution plan, and etc. We'll look at it, we'll inspect it, each and everything, but when the time comes, we'll do that. But as of now, I just want to say that you can change the display name of this job. So since this is building my code, I can say code build. I can just give a dummy name to the job out here, and it's also asking me what is the agent pool, and it's saying inherit from the pipeline, meaning whatever it is declared at the pipeline level, please go ahead and take the same agent or take the same machine in order to run all these tasks out here. This is what it is telling right now, and these are the actual tasks. So let's understand this or let's understand all these tasks as and when the pipeline is actually running. So how do I run this pipeline? Is I'll just say save, and I'll say save in queue, and I'll just add a comment that this is the first run, and I'll say save and run. I'll just say leave this page, and right now my pipeline is now running. So let me open this in a separate tab. Right now my pipeline is right now running out here, and there are a few steps that are mentioned in the pipeline. So all these are the steps that are mentioned inside the pipeline, which is called use, and I mean use.net and use new get restore and all that stuff. We'll look into that in one we'll look into that in a minute. But all these steps are right now being executed on the cloud. All the steps are automatically being executed as and when I said save and run out here. So any questions still here, guys?
So we need to use all the builds, right? Choose one.
I'm sorry, I didn't get your question.
No, no. You mentioned netgate and net. You have mentioned all the builds, right?
All the builds as in I didn't
So
get
we
you.
need
Sorry,
we
can
need to choose. No, we need to choose one build or cold builds. You see, net get restore and use net 4.41. These are
you.
builds, right?
They're not builds, they are tasks inside a build pipeline.
Okay. Mhm.
So they're not build, it is task inside a build pipeline out here.
Okay.
Just give me a minute, I'll just have a sip of water and come back. Just give me one quick minute, guys.
Okay.
Okay, I'm back. Okay, so these are not build. This entire thing that you see on my screen is the build, but these are all the tasks inside the build, and all these tasks together help me to do a restore, build and compile the application, and also to compile the application. So all this together will help me in one common goal. So what does this task really mean out here? And if I look at the pipeline run right now, I'm able to see that the entire pipeline got successfully executed. So what does this really mean? So let me go into each and every task out here, and let's understand what the task is really doing out here. So the first thing which you do not see here is called initialize job. Now, what is it trying to do exactly? Is that these two tasks are called pre-build. Why are they called pre-build? Is because I haven't mentioned that anywhere in my pipeline, but they're still getting executed, and they're getting executed for one specific reason. What is that? Is let's look at this. In the initialize job, my pipeline is going to Microsoft and requesting for an agent, because my pipeline knows that without an agent, meaning without a virtual machine, I cannot go ahead and achieve all these tasks. That is established, right? So it's going to, let's say, the servers of Microsoft, and it is requesting for an agent machine. And Microsoft in return said that, okay, fine, I understand you want a hosted machine. So this is the name of the VM. Is this VM running in your Azure portal? No. If I go into my Azure portal, this is my Azure portal out here. If I go here and if I look at the virtual machines that I have, I have nothing. There is nothing inside my portal. So where is this running? It is running on the Microsoft servers. This is managed entirely by the Microsoft. It's managed entirely by Microsoft. You cannot interact with this machine. you can just use this machine for a temporary or let's say for a temporary point in time. So that's the reason the first thing or the very first thing that's happening out here is that it's going ahead and going and getting an agent machine with this particular name, with any particular name out here, and it's just telling that okay fine, it's telling okay fine, the agent machine has acquired, and it's giving me the properties of the machine. Like for example, it's telling me that it's a Microsoft Server 2019 with some kind of, let's say, version of the operating system which is running on top of it, and which is a data center, meaning which is nothing but a virtual machine out here. And it's just telling me that okay fine, I have acquired this particular agent, and now I am ready to go ahead and execute your job, or I am rather ready to go ahead and convert your code. But before I convert the code, the reason I am able to do a build out here is because this code exists on my local machine. This code exists, the entire code definition is there on my local machine somewhere in some path. So since it's there, I'm able to go ahead and do a build process. If the code is not there, then there is no point in going ahead and doing a build process, right? I cannot build which is not present in my local machine already. The same applies to the virtual machine also, right? If this virtual machine needs to build the code, it needs to have the code on the machine itself. For that reason, the second step is called checkout repository, wherein if you look at, or if you carefully look at this, it's just going ahead and downloading all the code from my repository called as the first repository from the develop branch to a folder called as source directory on the agent. Now I'm talking about two different things out here. One, I said there is something called artifact staging directory where all the compiled code is stored. There is another folder called sources directory or source directory on the agent machine, which is represented by a symbol called S. It's nothing but a folder inside the virtual machine where the entire code gets downloaded. So the code from a branch called develop branch in a repository called first repository is being downloaded onto an S folder, or also called as the sources folder or the sources directory on the agent using this particular step. Once this gets downloaded, the code is now ready. You can now go ahead and do a build, but there is a problem. This is a .NET Full Framework application, and in order to restore all the dependencies that I have, I need a tool. I need someone called as NuGet. I need this tool out here. So what this pipeline now is doing, or what the pipeline now is doing, is that it's going ahead into a website called NuGet something something something. So if I click on this link out here, if I click on this particular link, all that happens is that I get a software called NuGet.exe being downloaded in my local machine. So I just clicked on this link and the software got downloaded. So what this step on the Azure DevOps pipeline is doing is that it's going ahead into this link called NuGet.exe, and it is downloading this particular file called NuGet.exe on the agent into a folder called C hosted tools Windows, something like this. It's downloading this particular exe file into a folder, and it's appending something called a path variable, a path environment variable, in order to make sure to use this tool. So firstly, it's downloading the tool called NuGet.exe, A reason being, it needs this tool to do a very important step called as restore. So it's using the tool that is there right now in order to restore all my dependencies, and it's now telling that okay fine, the dependencies have been restored. And finally, after the dependencies were restored, I'm now doing a build solution. So I'm making sure to build both my dependencies and the code. And there is something called test assemblies out here and publish symbol paths. Publish symbol paths is actually, we don't use this task a lot, but test assemblies is used to run test cases on something that you have built. In my case, I do not have any test case right now because I have just created a very simple code without any test cases to test it. So even this step doesn't make a lot of sense in our pipeline. I have just put these two steps just for the sake of it. And once this is done, my code is compiled here. The build solution is compiling my entire code, and all the compiled code is being pushed into something called as the artifact staging directory or the drop location in this particular step. So if I go into the step out here, all this is doing is that it's uploading the code, or it's uploading everything into a folder called drop. And finally, when I just look at this pipeline, this is something that I'm really interested in. It says one published, and if I go in here, it says something called drop, and inside this, the very important file that I actually want to look at is something called .NET Full Framework Application .zip. This is all my compiled, or this is all the compiled application that I do have right now, meaning if I now download this out and if I extract it into my local machine, it is just going to show me all the compiled application that the pipeline has done. So if I just go into the folder, if I just go into the folder out here, and if I just extract this out, and if I look into the extracted folder, it's just going to have all the application that is compiled. So it has content and it has a lot of internal folders inside it. And finally, I have a folder called bin. Inside this, I have all the application that got converted into something called as a DLLs. So you see DLL, DLL, DLL and all that stuff. This is the runnable version of my application. I get the same output even if I do a build process from my local machine. If I do a build process from my local machine, I get the same thing again. So it's now doing a build, and once it's done doing a build, I'll also take you to that particular folder in order to show you how it looks like. So it's now telling me that okay fine, this is the folder in which all the build application is there. So to see user something like this. So if I now go into that particular folder, same thing got built, but in a different configuration, of course. So all these files that you see here are from my local machine. This is from the local build. This is a local build. And if I just compare it with the one that I got from the pipeline, the number of files are of course less because I built it in something called as a release configuration. We'll talk about that. But all the main files that I do have, or all the main files that I need, now exists as an output from the pipeline. So this is the entire procedure of the build, and I just have covered how the .NET framework gets built. I have not covered how the .NET full or how the .NET core basically gets built. So we'll look at .NET core in tomorrow's session. But in today's session, I just want to establish the basics of build pipeline in by going through each and every step of the build pipeline and helping you all understand what that is. So any questions for today, guys? Any questions till now that I can take? Anyone, any questions till now? Anyone, anything till now? And guys, please make sure to ask questions. Please make sure to ask questions. If you're not following, I'm okay to go ahead and explain this again. There is no issue with that. But the main intention is that you'll have to understand this, because this is going to be our core job, guys. This is, as a DevOps engineer, this is the core area where we are working on. So please make sure to ask as many as questions if you have anything, and I'll make sure to explain it again if you do not follow it out. So anything before we close, guys?
And Kiran, like still we need to perform tasks, right?
We need to perform tasks, as in like you're saying this is not automated.
Yeah. Like build solution, test assemblies, like publishing. This
Yeah,
has to be done for the full framework.
it even it gets done for core also. Like even for a core application, you will have the tasks like build, test assemblies and everything. The restoration is going to be a little different. The restoration
Okay.
only is going to be a little different. But I mean, this is just a build pipeline. It's not a continuous integration pipeline. I have not automated it yet. So we will have to automate it a bit further to make sure that everything is automatically done without human intervention.
Okay. Yes, Kiran.
Okay, so any more questions here, guys? Okay, so if no more further questions, then I'm going to close, guys, and we'll meet tomorrow at the same time and we'll discuss more on this. Thank you, guys.